Okay, so we've been talking about slopes of tangent lines. At a point A, so I'm just going to kind of review that. We said that that's the limit as h goes to 0, f of a plus h minus f of a, which again, that's just the slope formula, rise over 1, which you'll see again. I'll draw a picture. And to emphasize this is the same as the instantaneous velocity at an instant at point A, or time t, and that's the rate of same thing. All these are the same thing. Rate of change at, and usually this is at a certain time, A. In this case we use A, usually it's t. Alright, since it has so many meanings, the same thing has so many meanings, we're going to define it. Here's a definition. And we're going to say that that's called the derivative of a function. And the derivative of a function, we're going to use the symbol f prime of a, and we're going to call that f prime. And that's equal to the limit, again, as h goes to 0, f of a plus h minus f of a all over h. Or you can use this formula, x approaches a, f of x minus f of a all over x minus a. Okay, so let me draw a picture. X and y axis. And here's our function. And here's our point A. Sorry about that. And we're going to move over by a distance h. So we'll say this is going to be A plus h. So this makes this f of a. This distance here is f of a. Remember, the function value is the y value. This distance, this point right here is f of a plus h, so that's this distance. And we're going to draw this line, that's called the secant line. Secant line is a line through 2 points, and that slope is rise over run. The run, this is going to be run, is h, and the rise is the difference in the y values. And so that's the slope of the secant line. And then when we put the limit in front of it, that's how we get the slope of the tangent line. Okay, so remember the limit, what's going on there, let me just draw a quick picture, is that h is going to 0, so this distance is closing in, and all these secant lines between those 2 points, as the point moves on this curve, is getting closer and closer and closer to the tangent line. So all these secant lines approach the tangent line as the distance goes to 0. Remember, h is the distance between a and a plus h. And the same way you can explain f of x minus f of a over x minus a. Again, that's a slope formula. It's the difference in the y's over the difference in the x's. So for an example, let's just do another picture. Pictures help. Suppose this is 1 and this is 2. And say our function goes like that. Then that point right here would be f of 1. And actually, I don't care if this is 2, so let me erase that. Let's say I move over by h. So we're going to label that distance h. What would this be? Well, you're adding h to 1, so that'd be 1 plus h. So the y value that goes with it is f of 1 plus h. Okay, so this distance is f of 1. This distance is f of 1 plus h. The difference in blue is going to be f of 1 plus h minus f of 1. That's right here. It's the tall distance minus the short distance. The change, and this is also the change in the y. So that's rise. And this right here is h, and that's your run. So again, rise over run is f of x, or f of, in this case, 1 plus h minus f of 1 all over h. Okay, so that's just labeling everything so you get a picture of what this is. And here's the secant line, and that's going to be the slope of that secant line. So if it asks us to find a derivative, we're actually finding the slope of the tangent line. We're also finding the velocity at a point. We're also finding the rate of change, how fast it changes. So this is the slope. It's also the instantaneous velocity. I'm just trying to emphasize this. And it's also the rate of change. Okay, so let's do a specific example. There's our function. We want to find f prime of a. Okay, so there's some steps here. First, we're going to do f of a plus h. So this says replace x by a plus h with a plus h. Or here, I guess these are in terms of t. So this is a t. So there's a t. Everywhere there's a t, you're going to put in an a plus h. So I'm going to put a plus h squared minus 2a plus h plus 1. So everywhere there's a t, substitute in a plus h. That's what this means. Substitute a plus h in for x or t. In this case, I use t. Okay, multiply that out. Let's FOIL it. Okay, second step, find f of a. Well, that means substitute a in for t. So again, wherever there's a t, I'm putting an a. So that's a squared minus 2a plus 1. Okay, third step, subtract. Now anything that's alike is going to subtract out. So what I'm doing is subtracting this and this. A squared minus a squared minus 2a, that's going to be a plus 2a. Anything that's alike is going to subtract out. 5 minus 5 is 0. So what am I left with? I'm left with 2ah plus h squared minus 2h. Factor out of h. Out of everything. Divide by h. Okay, remember the formula I'm using. So this is step 1. This is step 2. This is step 3. 4 is to factor out the h. 5 is to divide by h, and that should cancel. And 6, take the limit. So let all your h's go to 0. and I get 2a minus 2. Again, that's the slope of the tangent line at a point, so at any point A. So if it asks us to find the equation of the tangent line at the point 2, 1, okay, let's make sure, let's go back, we're using the same function. I'm going to go back up and look at the function. If I plug 2 in here, I get 2 squared minus 2 times 2 plus 1, and that's 1. So f of 2 is 1. So the point 2, 1 is on the graph. You have to check that. And you should check that. Now here, okay, we're right here. I know that this right here is f prime at a point A. At any point, this is the slope of the tangent line at any x, or A. A is x. So here's my x value 2. I'm going to take that and plug that in. So f prime of 2 is 4 minus 2, which is 2. So the slope of the tangent line is 2. That's what the derivative is. It's the slope of the tangent line. To find an equation of a line, I use the line equation. My y0 is 1. This is my y. y0, x0 is there. Equals my slope is 2. My x0 is 2. So simplifying that, I get y equal 2x minus 4 plus 1 is minus 3. That's my tangent line. And so if I draw a picture of this, okay, at 2, 1, here I am. My slope of the tangent line is 2. And let's see. Okay, just happens to be, if I draw the parabola, the function was t squared minus 2t plus 1. And okay, it goes through. This is 1, this is 2. It goes to the point 2, 1. And my tangent line right here, there's my tangent line. The equation is y equal 2x minus 3, and its slope is 2, and it's to the point 2, 1. So that's what a picture of that looks like. Well, what do you think the tangent line would be in this case, the slope? The slope of a horizontal line is 0. So at this point right here at the vertex, the slope is 0. Or if you had a parabola opening up, that's a horizontal tangent line, so the slope is 0. So slopes of horizontal tangent lines are equal to 0. So if f prime of A is 0, then you know you have a horizontal tangent line. The derivative is 0, you have a horizontal tangent line, and that's an important fact. Okay, look at some of the homework problems to help you.